Okay, class, this is the last video on the digestive system. We're going to be doing the liver, gallbladder, and pancreas. These are all accessory organs. Remember, they're not part of the GI tract. They are all aiding in the chemical breaking down of food, and they all function as exocrine glands. Remember, exocrine. They're secreting into ducts, and they're transporting their secretions through ducts into the GI tract. So let's start with the liver. So the liver is your largest internal organ. It is huge. Here we see it on the model here, torso model. It takes up a huge part of your abdominal cavity in the right upper quadrant, all the way mid and part of the right upper quadrant, left upper quadrant too. This is huge. It weighs 3.5 to 4 pounds, and it is just below the diaphragm. This shows it is right underneath the diaphragm. Here's the diaphragm here, and there's actually going to be ligaments that are coming from the liver that are going to be attaching it to the underside of the diaphragm. It has this reddish brown color because it is so vascular. There's lots of blood flowing into this liver, and it receives 25 to 30% of your cardiac output, your resting cardiac output. And it's responsible for 20% of your resting O2 consumption. So this organ is doing a lot of stuff for you. And just as a reminder, if you hear that term hepato, it is referring to the liver. Like hepatocytes, those are liver cells. Hepatitis, that is inflammation of the liver. So the gross anatomy, we are going to only be talking about these two lobes. There's 4 lobes, 2 on the underside that we're not going to be talking about. So you just need to know this right lobe and the left lobe. And they are separated by this ligament. It's called the falciform ligament that you need to know. And it is attaching the liver to the abdominal wall. And there's going to be some ligaments that are attaching this liver right underneath the diaphragm. This is a huge organ, and it is being held in place by these ligaments. There's also a little round ligament. Here's the falciform ligament. And there's going to be a little round ligament that comes out. And on a cadaver, this round ligament, it will be connected to the umbilicus, the belly button. And that was a remnant of the umbilical vein from the placenta of your mom. So that's kind of cool. Now, there's hundreds of functions of the liver. The main ones that you need to know are it is synthesizing a bunch of stuff. It's synthesizing proteins, and the main protein that's in plasma is albumin. That is all coming from the liver. It's synthesizing clotting factors, bile that we're going to be talking about today, and cholesterol. Now remember, there is good cholesterol and bad cholesterol. The way you guys remember HDL and LDL, which one's good, which one's bad. LDL, L stands for lousy, it's your bad one. HDL, H stands for happy, it's your good cholesterol. And it's also a storage site for iron, glycogen. We've talked about glycogen before. That's just stored glucose. It stores blood and some fat-soluble vitamins. This is why people like to eat liver. They said liver is a healthy organ because it has all this stuff. But don't eat liver unless you know where it's coming from. and it has lots of metabolic functions. The ones we're going to be talking about is it will convert glucose to glycogen, and it's going to convert glucose to glycogen after you've eaten a heavy meal and there's extra glucose. It will turn it into glycogen. And if you need glucose, it will turn that glycogen back into glucose. It's also going to convert carbohydrates into fat. And one of the main metabolic functions too is this liver is helping to maintain normal blood glucose levels. And in nursing or any healthcare field where you're using medications, it is going to be the site of detoxification of many drugs. We're talking about legal and illegal drugs and poisons. So let's have a look. I just wanted to bring this out before we get started. One of the main proteins that the liver is making is albumin, and this is in your plasma. And albumin is helping to keep fluid, water in your blood vessels so it doesn't leak into your tissues. If you don't have albumin, you're going to be losing fluid out of your blood vessels, and it will go into your interstitial space, your tissues, and third spacing into cavities. So here they're showing third spacing into the peritoneal cavity, and this is called ascites when you start losing fluid into this peritoneal cavity. That is why you have this. So when you see someone who is starving, this child is starving. This is ascites. This child is third spacing. Why? There is this poor little thing does not have albumin. There's no albumin to be holding the blood in this little one's blood vessels. Why doesn't this little one have albumin? Because you need protein, you need amino acids to make albumin. When you're starving, you can't do that. So we said that the liver was a bloody organ. It's really dark brown red. That's because there's lots of blood flowing to it. It has a dual blood supply. There are two sources of blood going into the liver. The first one you already know about. We have our celiac trunk coming off of our abdominal aorta, and one of the branches of the celiac trunk was the hepatic artery. So that is going to be taking oxygenated blood, nutrient-rich blood into the liver. And then we have this second source of blood, the hepatic portal vein. This hepatic portal vein, this is the veins that are coming from all these organs: stomach, spleen, pancreas, all the small intestines and large intestines. When we looked at our veins, when you had to learn about veins that were going back to the heart, this is all you saw was these hepatic veins. We know the liver's here, but you only saw this. You only saw the part that was leaving the liver. These hepatic veins are draining, leaving the liver, and taking it back to the inferior vena cava. But this hepatic portal vein is going into the liver. So I'll show you some more pictures if you don't quite understand it. So these are all the veins that are leaving these organs: the stomach, the spleen, the pancreas, the large and small intestines. So all these veins that are leaving all these organs are going to be coming together, joining to form this hepatic portal vein. And this hepatic portal vein will then be taking all the used up blood from these organs into the liver. Now this hepatic portal vein, this is O2 poor blood. That makes sense. O2 poor blood. This is the blood that's draining, leaving these organs. But it is nutrient rich. Why is it nutrient rich? It is leaving the small intestines. I'll show you that in a second. And all this blood has not been detoxified by the liver. If you just ate a big meal and you just had a fifth of whiskey, that is going to be absorbed and it's going to be taken into the hepatic portal vein, and the liver is going to process everything you ate and drank before it leaves through the hepatic veins back to the inferior vena cava. So let me show you why it's nutrient rich. So remember this? This is a plicae circularis from, well actually this is one, this is the plicae. This is one intestinal villi. This is from the small intestines. We have our simple columnar with microvilli. And in this lamina propria, we have our capillaries. So our capillaries those are the blood vessels that are going to be absorbing all the nutrients. Everything that you ate or drank is going to be absorbed through these simple columnar cells with microvilli into our capillary beds. And then remember, capillary beds, they turn into veins. So arteries, we've got the little arterioles, capillary beds, veins. So this vein that is leaving this intestinal villi is filled with nutrients. If you just ate a meal, this is filled with nutrients. So here we have our dual blood supply again, the hepatic artery that you know is O2 rich, and it is nutrient rich. Everything here is nutrient rich. This is what's feeding your entire body, this aorta. And now we're going to take all this nutrient-rich, O2-rich blood to all our digestive tract organs. We're going to go through those capillary beds, and we are taking all the nutrients and anything else that you ingested. We are taking it into our capillaries, and that is going to be leaving all those organs through their veins and joining to form the hepatic portal vein that is going into the liver. So hopefully that makes sense. And then once the liver processes all this blood that's going through it, it will leave the liver and go out through the hepatic veins back to the inferior vena cava, back to the heart. So let's go through these two dual blood supplies again. Hepatic arteries, O2 rich, yes, coming straight off of the abdominal or aorta. Nutrient rich, yes, coming straight off of the abdominal aorta. And it's been detoxified by the liver at least once. Now the hepatic portal vein, this is O2 poor. This is draining all the organs in the abdomen. So it is O2 poor, but it is nutrient rich. It's nutrient rich because I just showed you why it's nutrient rich. All the food and drink that you just had is being drained into this hepatic portal vein. And it has not been detoxified. It has not gone into the liver for any processing. I call this magic. The liver's going to do magic with all this blood that's going into it. And it's trying to protect you and detoxify anything before it reaches these hepatic veins. Because once it gets into these hepatic veins, it's going to be taken to the inferior vena cava, and that's going to take it to the heart. And once it gets to the heart, it's going to go through your entire body. So if you look at this diagram, you see there's 2 blood vessels going in. Here is our hepatic artery, the red one. This big blue guy, not blue, he's purple. This big purple blood vessel, that is your hepatic portal vein. He is huge, probably 4 times as large as this hepatic artery. He is huge. Those 2 blood vessels are going into the liver. And then we have this bile duct leaving this liver. We talked about this already. We were doing the GI tract, but this is leaving the liver. The liver is going to make bile, and it's going to leave through this bile duct. So we're going to look at these 3 structures next. So the liver basically is just a collection of these guys. So this is a histo slide of the liver. These are called hepatic lobules. You have over 1 million of them. This is what the liver is. This guy, this hepatic lobule, is doing the same thing as this hepatic lobule. They are the functional units of the liver. They are all doing the same thing. They are all built basically the same way. They are separated by connective tissue. And let's look at what each of these hepatic lobules, what one of them would look like. So here is our little hexagon. Here's our hepatic lobule. It has those 3 things we just saw. We are seeing a branch of the hepatic portal vein. So there's a branch coming into each of these. There's a branch of the hepatic artery. That is our dual blood supply. And then we have a little bile duct. So these three things are what you just saw. They're little branches of these 3 things right there. And these are called the portal triad. Triad because there's 3 of them. You need to know what they are. You need to know the 2 blood vessels are going to be a branch of the hepatic portal vein and a branch of the hepatic artery. Do not put this is the hepatic portal vein. This is not the hepatic portal vein. This is itty witty. You've got 1 million of these hepatic lobules that these guys are going to. So let's have a look at this in more detail. So here it is. What is going on in here? So each hepatic lobule, you know about the portal triad. We have our 2 blood vessels that are taking their blood, and they're going to send it through these areas of the lobule called a sinusoid. Sinusoid, these are just large capillaries. This is a capillary. So this just has endothelium. Endothelium here. This is all hepatocytes, the cells of the liver. So we've got these sinusoids, these little blood channels that are carrying our blood from the hepatic portal vein branch and our hepatic artery branch. It's sending down through these sinusoids, and they're sending their blood through into this structure, the central vein. Now this central vein, remember you've got like 1 million of them. These central veins are going to join together and form your hepatic veins that will then go on to go into the inferior vena cava. So we have these sinusoids where the blood is going, and there's only one layer, maximum two, of hepatocytes. So these hepatocytes are having direct contact, one-on-one contact with all the blood that is going through them. So these hepatocytes are monitoring what is in that blood. What kind of chemicals are in their blood? Is there anything toxic that these hepatocytes need to detoxify? So these hepatocytes are going to have lots of enzymes that can break down different things that you might have ingested. So even alcohol, let's just talk about alcohol because we know that's something people ingest. There are enzymes that the liver is throwing out into the blood to detoxify that alcohol. It's called alcohol dehydrogenase. Now, it may not be able to detoxify all the alcohol before it gets to that central vein and goes on to the rest of your body, but that blood's going to be keep coming back to the liver, and eventually it will break down all that alcohol, and your blood alcohol level will get back down to 0. And then we have these little guys. These are Kupffer cells. Kupffer cells. These are resident macrophages. They are lining the sinusoids. What are they doing? They're doing what macrophages do. Is there any bacteria left in the blood here that's coming from the GI tract? They're going to make sure if there's any bacteria in here, hopefully they can take it out before it gets to the central vein. They're also removing old, worn-out red blood cells. We said red blood cells, they last around 120 days. Once they get old, these Kupffer cells, they're going to phagocytize them, take them out of the circulation. And if there's any heavy metals, they will also try to ingest any heavy metals before they get here. So they're doing a lot of monitoring of the blood that's going through here. And these hepatocytes are making bile. So they are making bile and they are secreting it into this little canal. It's called a bile canaliculi. You've heard that word before. A bile canaliculi, and it's sending it into this bile duct. So the blood is going in towards the central vein. The hepatocytes are making bile and it's sending it out into the bile duct. You must understand, bile has no contact with the blood sinusoids at all. If bile got in here, it would destroy your red blood cells. So it has its own little canal that's taking it to this bile duct. So that is essentially what this hepatic lobule is doing. And you've got a million of them. So make sure you understand what is going on in here. So here's showing you a close-up of one hepatic lobule. Remember, this hepatic lobule, this is going to be connective tissue that's separating them. All this are hepatocytes. Here is the central vein. The sinusoids, those little blood capillary channels, are these white little parts. So if you do a close-up, here is your central vein. All this white stuff, these are the sinusoids. So the blood is trickling in through here, going through all these hepatocytes. So these hepatocytes are monitoring all that blood that's going through those sinusoids. And you can actually see, let me get this over here a little bit, you can actually see See these black little things? These are Kupffer cells. We've got Kupffer cells all over the place here. Kupffer cells, Kupffer cells. More of them here. These Kupffer cells are lining all the sinusoids. They're amazing. So what you're going to see, get this back down. What you're going to be seeing in any textbook is something like this. So this is showing you 1, 2, 3, 4 hepatic lobules. And they're taking a little section and they're showing you this. So this is from your worksheet, this exact same picture. This is your central vein. Here is a branch of the hepatic portal vein, much bigger than the hepatic artery branch. So we have the branch of the hepatic portal vein, the branch of the hepatic artery. They're sending their blood into this sinusoid. These are all sinusoids. If you can see the Kupffer cells here lining the sinusoids, those macrophages. And then here is the hepatocytes, these tan-colored structures, and they have a little canal in them. That's the bile canaliculi, and they're sending that synthesized bile into the bile duct. So make sure you understand what's going on here and all those parts. You have to know that. So I just wanted to bring in this stages of liver damage. Fatty liver, that's the first stage. You're going to see lots of fat accumulating in the liver. The liver is not working right. It's been damaged in some way, and the mitochondria in the liver can't process the fat. The next stage is going to be liver fibrosis. Once the hepatocytes are damaged, they're going to try to heal, and that connective tissue that is surrounding each of those lobules is going to become thicker. They call it scar tissue is forming. And it's fibrosis because it's the fiber in those connective tissue, those collagen and elastic fibers in that connective tissue. The last stage is cirrhosis. That connective tissue is basically almost all connective tissue, and the hepatocytes have been destroyed. So once you're in cirrhosis, there's not much blood flowing in through here. It's all fibrous connective tissue. So I wanted to show you what happens when you have cirrhosis. So here is Medusa and her wild snake-type hair. And this is what they call, when you have cirrhosis of the liver, end-stage liver disease, you have this. It's caput medusa. That's what they're calling it. This is all dilated blood vessels. And where are these blood vessels coming from? Well, it's coming from all of these blood vessels. All of these veins are trying to get into the liver. But now the liver is scarred down. It's just, there's not much hepatocytes left. Most of it is just connective tissue. So all this blood is trying to get through a liver that is now nothing but connective tissue. So where does the blood go? It's backing up. It can't get through the liver. That's called portal hypertension. Portal hypertension. This patient also, both of them have ascites. Just like our starving little boy, this patient has ascites too, but for a different reason. The liver's not making albumin here either because the liver is non-functioning. This is end-stage liver disease, and these patients, they will die. So now we're going to go on to the gallbladder. The gallbladder is just a smooth muscle sac. It's a little organ made of smooth muscle that sits right underneath the inferior surface of the liver. Its job is to receive the bile that has been made by the liver and store it and concentrate it. And then when you eat, when you're eating a fatty meal, the parasympathetic nervous system will squeeze the gallbladder and it will send out that concentrated bile down through the common bile duct and into the duodenum. So you need to know these ducts. So they're not that hard because just look at the word. Right hepatic duct. We have a right lobe and a left lobe. This right hepatic duct is coming from the right lobe. Hepatic means liver. So right liver duct, left liver duct. These right and left hepatic ducts are going to join together to form a common hepatic duct. And from the common hepatic duct, it's going to send that bile that the liver made into a cystic duct. This cystic duct is taking that bile into the gallbladder. When the gallbladder is activated and contracts when you're eating a meal, it will send the bile back out through the cystic duct into the common bile duct, where it will join the pancreatic duct, and together they're going to form the hepatopancreatic ampulla. This is all review, and it's sending the secretions into the duodenum. So this part is all review. So make sure you know these ducts. You have to know these ducts and the order in which they are taking that bile. Well, what does bile do? We say it emulsifies fats. What does that mean? So once you add bile, bile is just, they call it bile salts. It's a salt. If you have a big fat droplet and you add bile salts, it will emulsify it, which means it's going to break it down into smaller droplets of fat. If you've ever washed dishes and you had a big glob of fat and you pour in your detergent to wash your dishes, it's going to make your big fat globules into smaller fat globules. That is what bile salts are doing. When you have these smaller droplets of fat, the pancreatic lipase, one of the enzymes, digestive enzymes from the pancreas that's being dumped in, it can work on these fat droplets a lot easier. There's a lot more surface area here for that lipase, and then it's going to break down the fat into absorbable units in the small intestines. Now you can get gallstones. This is a bile salt. With any kind of salt, it can crystallize out and it can form gallstones. Most of the time, gallstones can be asymptomatic. You don't even know you have them. Once in a while, you will know you have them after you've eaten. If your gallbladder contracts and you get a gallstone that's blocking the cystic duct, that will cause severe right upper quadrant pain, and the pain will come and go. When the gallbladder is contracting, lots of pain, and then the gallbladder is going to relax. The pain will go back down. Now, depending on where that gallstone might get stuck, if it gets stuck here, or if it gets stuck in the common bile duct, or if it gets stuck right here where the pancreatic and the common bile duct meet, you can be blocking pancreatic enzymes you can be blocking all the bile that's trying to come down here. This can be a medical emergency. So depending on where that stone might cause a blockage, it can be a major problem. So who's at high risk for developing gallstones? We call them the 4 F's. Female, fat, fertile, and 40. Female, overweight, they haven't gone through menopause, and they're usually in their 40s. That's just a general rule. I mean, obviously, there's some people over in their 60s, and they could be men too. But those are the highest risk group, that group. Now, this is just a little humor. If you like anatomy humor, go to this website. Here is the liver talking to the gallbladder. The liver has lots of jobs. It has 200 plus functions to do. And he goes, "What is it, gallbladder? Can't you see I have a lot to do? I'm busy." And the gallbladder says, "I made these. You made stones? You're just supposed to hold on to what I give you. Get out of here." The gallbladder, the only job he has is to hold the bile. That's it. So I thought it's really cute. And you just cause problems when you make those stones. Now we're on to our last organ, the pancreas. Now the pancreas has both is both an exocrine and an endocrine gland. Now the exocrine, that's what we've been talking about in the digestive system. Pancreas secretes pancreatic enzymes. There's like 22 kinds. They're released into the duodenum via a duct. And those pancreatic enzymes are what we need to chemically digest our food. Without those enzymes, we cannot break down our food into absorbable units. And the cells of the pancreas that make all these digestive enzymes are the acinar cells in the pancreas. Now, in a histo slide, and you need to know this one, all the dark parts in here, those are all acinar cells. So anything that's the dark pink, those are acinar cells. As opposed to the endocrine portion of the pancreas. Endocrine, remember, they secrete hormones into the blood. It secretes 2 hormones. Everyone's heard of insulin. When your blood sugar levels are high, hyperglycemia, that means high blood sugar, insulin is going to be released. Only with insulin are your cells allowed to have glucose enter them. So you need insulin to let glucose be taken into your cells. And the other hormone is glucagon. When blood sugar levels are low, hypoglycemia, glucagon is released. This hormone will work on the liver. It will have the stored glycogen that's stored in your liver. And when glucagon is acting on that glycogen, that will cause the release of glucose into the blood. Glucagon and glycogen, always get those mixed up. And these 2 hormones are made in the pancreatic islet cells. They're easy to see. Here's a pancreatic islet cell, these light pink rounded structures in the pancreas. These are the pancreatic islet cells, also called the islets of Langerhans. So make sure you know this histo slide and you know all this stuff. And a good way for you guys to do this is write these down on cards or take little notes. I know I'm talking a lot, but you can be taking notes while I'm talking too and writing these down. Here's the gross anatomy of the pancreas. You've seen it a billion times by now. This is the head, body, and tail. They say it looks like a tadpole. Here's the pancreatic duct. Here is the dissection of the pancreas. You can see the duct real easily in here. And here is the head pressing against a cut section of the duodenum right here. And there you can see the plicae circularis in that duodenum. So that's it. We are done with the organs of the digestive system. When you're looking at listening to these lectures, you should be reading along with your lecture notes. I think I have 8 pages of lecture notes for the digestive system. Read them all. If it's highlighted in any way, it's a structure you need to know and need to understand. So that's it for the digestive system. We're going to go on to the urinary system.